Hello, in this video we're going to talk about how to use packaging in R and use the function and package to do certain tasks. Our first task is to do a forecasting on the number of births in New York. So this is the historical number of births in New York City. This is a monthly data from this year 1946 to 1960. So we want to predict what's the birth rate in the next 3 years. And we're going to use a state-of-art forecasting package called Forecast in R. Okay, let's go to our RStudio and open the shell I gave to you in the class. Go to the place where you store your shell. Mine, for me, is in this folder. Um, part 2, forecast shell. Okay, this this is the shell I gave to you in the class. So our first step is to install the forecast package. To run this code, it may take a little while. Make sure you have the internet connection, and this is we may have some problem installing this in the lab computer because it's in a network environment. It should be very stable when you're using your personal laptop. When you install this packaging, you can use this um, code to call the packaging into your code. And let's install this. Oh, what's this? I can't install this. Oh, you see, there's some network problem with my computers. All the icons in the desktop is with close. Let's just refresh this, see if I can solve this problem. Okay, that's too bad. Just bear with me for a moment. It usually happens when you are in a network computers. They have this weird thing happening. Okay, should be good. Let me try this again. Install packaging, missing true or need. Ah man, what's going on? No, this. No, you can't open the folder. Ah, too bad, too bad. I call the exclusion error. Oh, this no internet connection. Oh, this is just a real case of my life. Okay, finally it's working. Okay, now it's working. Let's install the package for now. Okay, great. It seems it's working now. Okay. So while we're doing this, I can talk about a little bit why we have packaging in R. So the developer, they try to make this program small so they don't install all the function within this program. So when you need something, you just go to the web and download the packaging. So when you download the packaging with this code, and you have to call this package, call this function into memory. So you have to call library. So you have to load this into your memory so that you can use the function here. And this code is just to remove all the objects that is already in your memory within R. So we clean this variable or data you already have. Okay. And now we are going to first we're going to do is to read the data. You can read the data by the original way we have, basically to write down the path of the data and then read CSV, or you can read the data directly from online because the data is already in the website. So you can take a look at this. So this is the data is already on site, so you can read directly from the website by using this scan um, uh, function. So as you see here, we read the data into birth, and now we are ready to do some analysis with this. First is let's just first print this variable first. Birth. It looks like this. As you see here, it's supposed to be a time series data, but there's no time dimension on this data, which means there's no column corresponding to which would which no there's no column which shows which year this number from. So we first task is to create a time series data. The function we'll use is the TS. So we first create a time series data birth TS time series with this TS function, and we pass the birth data into this function, and we are going to first tell the function that the frequency of this data is 12, which means it's a monthly data. If it's 4, means the data is quarterly, and it starts from, you're going to tell them which year it starts from and which month it starts from. So it's a vector. You're going to pass to the start parameter. So it's from line 1946. This is the year, and it starts from the first month. So this is the background information we already know, and we can run this code. Now we have a time series data, as you see here, time series data from this year to this year. And we can view the time series data by just printing this data. Okay, and now it looks different, right? With our compared to our original birth data. Now it's organized in years, and this we know, okay, this is the birth rate for each month. And we can easily plot this data by plot TS, TS. And this is exactly what we show in a PowerPoint, and you can enlarge this. So, and you can always import this as an image when you want to save the image. The next thing we want to do is to decompose this time series data into different components, because the reason they are changing with them is first they have some trend, and then they go up and down, that's seasonality. So we want to decompose this time series into different components, including seasonality, trend, and random component. The function we use is decompose. So we're going to pass our time series data into decompose function, and then save our result in a variable. Let me just write down the variable I want to store birth time series component compose. So we can run this code. Now we basically generate this object components. You see, you have different lists. You have the original data X, seasonal, trend, random, figures, and the type attributes, etc. The most important is the seasonal, trend, and random term, and we can plot this decomposed series of data. Let's just run this code, and let's see. Take a close look at this. So to see, this is the original data we observe, which is the monthly birth only, and there's obviously upgoing trend. So that means from this year 1946 to 1960, there's an upgoing trend of people who are born in New York City, and there's clearly some seasonality here. This is the month that being this month that this is the month that they would have least birth rate, and this is the month they have highest birth rate. And we can take a close look at the seasonality or trend by just printing out the different component. Birth TS compose. This is where we store our result. We can look at the seasonal component. As you see here, this is the seasonal component. It says it doesn't change with years because it's seasonal. It's just looking at what's the effect of being in January on the birth rate. What's the effect of February on the birth rate? As you see here, April. Okay, is that April? Yes. April seems to have the least birth rate among the 12 months, and August, I think it's August. August is the month that has highest birth rate. It seems that people tend to give to bear a child or to give birth to child in the summer, while they are less likely to do so in the winter. Yeah, people is because the weather. That makes sense, right? Okay, so next thing we want to do is to forecast. Okay, what's the birth rate would be in the next 3 years? The function we're going to use is forecast. And so let me just write the forecast down, and we're going to pass our birth time series data to this, and I'm going to tell, okay, we're going to forecast for the next 36 months. So we set H to 33, and we want to store the result into an object, birth, say birth forecast. And we can run this code. Now we have the result. It takes a few seconds, but it's pretty quick. And we can plot our result by using the function plot forecast. Okay, now we get a very nice graph, and it basically shows the actual data. And the blue line shows, okay, this is the forecast, and this dark interval, this is the interval estimate, because we can't make sure that is 100% with 100% certainty that in the next few months this is the exact number. So sometimes we have to give a confidence interval estimator, and this dark green is the 80% confidence interval. That means 80% of the chance the number will reach in this range, while the light green is the 95% confidence interval, which means 95% of the chance the number would in this light green interval. And we can actually we can actually print out the forecast results. But just run this code, we can see, okay, this is the result for each month. For the next 3 years, we have the point forecast, and we have the interval forecast with confidence level of 80, and we have the interval estimate with confidence level of 95. And we can also we can output this forecast result from this memory into our hard disk, so we can use it for future analysis. So the way to do this is, first we can go to the place where you want to store your data. Say you want to use the original path where your data is coming from, and you want to output the data into this directory. You want to give a name to this, say New York forecast. Now you can run this code. Oh, we got an error. Don't be panic. That usually happen. As you see here, it's a typo because I changed the name to birth forecast, but I don't have S here, so I should put an S here. Now let's run this code. Can't open connection. Okay, because let's see what happened here. Path file path. Not very sure what is happening. Let's see. Let me just run again. Error in writing files. Okay, let me just remove this and go to our original folder. Okay, so this is a place I want to put our data. Okay, and NY birth, that's the data from. Let me just copy this directory. So I put shift, copy path. Let me copy this from where I stored our data, and then make it name to, let's just call it NY birth 2, and then we have to replace this by this backwards slash into forward slash by the Control F, so we can replace this into a dash. Replace. Okay, and then let's run this code again. Now we get the result. So we go to this file nybirth2. This is where I output our result. Let's open this. You can see we successfully write the data into our file. So that's all about forecast. Thank you for watching.